A quick walkthrough video of this Web3 application, CryptoFlux. So Alchemy and other data providers do not always have the exact token price available on the blockchain for every specific timestamp. That's why I created this application. So I filled those gaps by fetching, interpolating, and storing historical prices to provide accurate token price data at any given timestamp. So this application have two parts. The first one is analyze token, and the other is the scheduling full history of the prices for every day since the token is created. And let me just show you how the what's the flow of the backend is. So here, as you can see, here is the Next.js front end. So three things are coming from the front end, and it's hitting the Node.js API. So we have two paths and two APIs for working of this whole application. The first one is for the analyze token, and the other one is for scheduling history. So when the user sends the token address and the network type and the timestamp, initially it checks the Redis cache, and if the price is available in the Redis cache, then it returns that price immediately. And if the cache fails, then it queries to the Alchemy API, and if the price, if the exact price, if at this timestamp is found, then that price is thrown back to the user here, and also it is stored in Redis and MongoDB for later use. And but if the price of this particular timestamp is not available, then we do the interpolation method, which is fetching the nearest price from this around this timestamp. For example, if the user enters timestamp for 10:43, and if the Alchemy APIs does not have that price for that particular timestamp, and but it does have the at maybe let's say 10:40 and 10:45, then we do the interpolation of all from those, and give the price to the user back, and also store in the Redis and MongoDB. So this was the for the scheduling for the API part for requesting the price at a particular timestamp, and the other part is scheduling the price. And how this works is the user enters the token address and selects the type of network associated with the address, and there we have the BullMQ and the daily schedule fetcher, and then we have the get token creation date function. It's a function which gives back the date when the token was deployed on the blockchain through the contract, or let's say when the token the birth of the token, it's that date. And from that day we generate timestamp, and but at particular time we check the price at that particular time every day, from the day that token was created to the current date. And then we do the batch Alchemy request, and we are not hitting the into Alchemy API at once, then to avoid the 429 status code. And so we do batch Alchemy request and store in the database. So let me show you how this practically works. So if I enter the token here, and this token belongs to the Ethereum, and let's enter the date, let's say 27 September or 24, and enter the time here, let's say 4:27 am. And if we do analyze token, you can see here we do get the historical price, and this is the current price, and this is the historical price, and this price is for this timestamp, 27 September 2024 4:27 a.m. and it's in the Indian Standard Time. And this is the token birth date. This is the time when token was created. And coming to the source part, yes, so we are getting the source from alchemy interpolated. So we have different sources. Let's say alchemy exact. So alchemy exact is when we enter the timestamp here, and it directly the price is directly found on the alchemy API, and without the interpolation method, then we store this method is we are naming it as alchemy exact. So this is coming from alchemy exact, and if the price is not found at this particular timestamp, and if we are using the interpolation method, then the source will be alchemy interpolated. And this will be when if the and this interpolated will means that when the nearest timestamps are not present for that particular day itself. So let's say if we want timestamp, and this was the particular price, and we are saving the source also, and this is the token address. So this is for the historical part. Now coming to the scheduled functionality. So for the same, we have to enter the token address and the network. For this we don't need the timestamp, because we are getting the prices from this date to the current date, and every day we are getting each one timestamp for each day for per day. And if I click to, and as you can see, now we are only having one. This is coming from the price we looked for analyze token part. And if I do the schedule full history, then it should save all the prices. Yes, so we got the alert. So for now I'm not populating the data here over directly, but the schedule is already working in the backend. And as you can see here, it's retrieving all the data from the alchemy API through our BullMQ, the jobs and the workers. So initially it's getting the token creation date, and then it's fetching the price for every day since the token was created. And while this retrieval process is happening, we can also look for the other token and analyze other token also at the same time. So this can be used in by various developers and who wants the data in bulk. So as we can also see here in the MongoDB, and if I hit the refresh button, so data from the alchemy API. So as we can see, it's coming from 2018, and the date was 20th November and 20th November 21st November. Here we can see it is 21st November, and here also it's coming from 20th, and so on. And it will keep on increasing to the current date. And as we can see, the initial date was 19th November, and let's see if yes, here also it's coming, it's 19th November since the birth of the token date. So this is how it's working, and right now I'm working on this schedule model, so to display the prices from MongoDB to over here, and that's it. Thank you.